Hi, everyone. Welcome. People are just filtering in now, so we're going to give it a minute or two before we get started. So those of you just signing in, good morning and welcome. We're just waiting for everyone to filter in, and then we're going to go ahead and get started. Good morning and welcome to those of you that are filtering in. We're going to go ahead and wait probably about another minute, and then we'll get started. Good morning to those of you that just signed on. We'll go ahead and get ready to get started here in about a minute. We're just letting students filter in. Okay, great. Again, welcome. We're going to go ahead and get started. Welcome to our final of 3 Penn Engineering PhD open houses. We are so happy that you could join us this morning or evening, depending on where you're signing on from. Today we'll be featuring the Bioengineering and the Mechanical Engineering and Applied Mechanics programs. We are recording this webinar and it will be on our YouTube page probably within the next few days, so no need to worry about taking notes or missing anything. You can also see our past webinars while you're there. If you have any questions, we ask that you please submit any questions to the Q&A section on your Zoom toolbar. There we'll have members of our team answering them on the back end, and also we will promote some to be answered live during Q&A sessions. I'm also joined by my amazing Penn Engineering colleagues, like I said, who will be answering questions on the back end. Today's agenda, we're going to go through introductions of the Penn Engineering team, going over the University of Pennsylvania, the PhD programs overview, admissions, bioengineering, and then mechanical engineering and applied mechanics. I'll go ahead and start with myself. My name is Jacqueline Aldworth, and I am the PhD admissions manager. You may have spoken with me via email. Abby Coxine is the Associate Director of Graduate Admissions, and she will be behind the scenes diligently responding to any questions that you may have. And lastly, we have Dr. Boontao Liu with us. He is the Senior Associate Dean for Education and Global Initiatives. I'm going to hand the presentation over to him for a moment.
Thank you, Jacqueline. First of all, welcome to everyone on this webinar. We have a large number of attendees, very excited about that. And today we're going to be presenting the bioengineering and also the mechanical engineering and applied mechanics department. As Jacqueline mentioned, my name is Boontao Liu. I'm the Senior Associate Dean and also faculty member in computer science and electrical engineering. I'll start off by saying now is a really exciting time to join our engineering school. We just opened the Bachelor's Laboratory for Energy Science and Technology. They'll be focusing on sustainable energy solutions. And also at the same time, we just recently had our inauguration ceremony for the Amy Gutman Hall, which is a state-of-the-art data science and computation research and education facility, and really putting us at the forefront of AI, robotics, and application of AI to health science. And at UCT Square, we are establishing a hub that bridges engineering and medicine. I'm sure this will be of strong interest to many of you interested in bioengineering, really to explore the use of engineering technologies to do much more advanced personalized healthcare. And if you're ever interested in entrepreneurship, there is now a Tangen Hall Venture Lab, which is a state-of-the-art facility jointly created between Wharton Business School, Engineering School, and also the Design School to promote student commercialization efforts. Now, Penn Engineering is very interdisciplinary. In fact, in our department such as bioengineering, which you will hear a lot about soon in a bit, there's a lot of collaboration between the medical school and our engineering school. And we have many of these interdisciplinary research efforts. For example, the GRAPS Lab for robotics, the ASAT Trustworthy AI, ideas, which is on using AI to solve engineering challenges. And I myself belong to a lab called the Distributed Systems Lab, which has many faculty and students working together in the areas of data center technology, cybersecurity, and so on. So once again, thank you for joining us. You will soon hear from many faculty members, coordinators, and students who can tell you about exciting research and also what it's like to be a student in Penn Engineering. And look forward to the rest of the webinar. I'll hand this off back to Jacqueline.
Thanks so much, Boone. Okay, moving forward, we're going to go over why the University of Pennsylvania. You obviously know a lot about your field that you're interested in studying. You have lots of choices, but why Penn? We're the first university in the nation. We were founded by Ben Franklin in 1740, and about 120 years, 10 years later, the Penn Engineering was founded. We are considered a large institution with over 26,000 students, and most of these students are being graduate students, which is fantastic. We occupy over 300 acres of land in the city of Philadelphia. There are 12 graduate schools across the university, Penn Engineering being one of them. We offer 14 master's programs and 6 Ph.D. programs. We have 19 research centers and institutes focusing on areas like AI, engineering and healthcare, and robotics. Access to incredible resources such as libraries, Center for Affinity Groups, multiple fitness centers, and career services support. We're located in the exciting, innovative city of Philadelphia, which I'll go into a little bit more next. Philadelphia is not just known as the birthplace of the nation, but we're also the city of brotherly love. The photo you are seeing here is looking west along the Schuylkill River. The Schuylkill River is famous for, if anyone's familiar with rowing, it's a kind of the birthplace of rowing in the United States. The Philadelphia has played an extensive role in United States history. We were founded in 1682 by William Penn, an English Quaker, where our mascot pays homage to English Quakers, and he was an advocate of religious freedom at the time. We may be the sixth largest city in the nation, but we are also the first in the nation for many. The first planned city, the first library, the first daily newspaper, hospital, and art museum, to name a few. Like I said, rich with history, art, and culture, festivals, and educational opportunities, there's truly always something to do here in Philadelphia. One of the great things about Philadelphia, it's a very affordable cost of living compared to other East Coast cities. We're located just 2 hours from New York City and DC, and we're easily commutable by train or car to other cities, like even Baltimore is about 90 minutes away. And it's also accessible by public transportation. Although many of our students live on campus, there are a lot of amazing neighborhoods to check out. We are home to the largest urban park in the world, known as Fairmount Park, where you can bike, row, hike, walk, horseback ride, and explore. Philadelphia has turned into a hub of life sciences for tech, manufacturing, and science centers. We also maintain an extensive contemporary influence in business and industry, culture, sports, and music. So going into the academic programming today, if you may not know, we do have 6 PhD programs here at Penn Engineering. Bioengineering, which is one of the programs we're covering today, chemical and biomolecular engineering, computer and information science, electrical and systems engineering, material science and engineering, and the other program we're covering today is mechanical engineering and applied mechanics. The fun part, the application requirements. The online application consists of the following materials as well as personal information about yourself. It's also noted that if you are not aware, the application is open currently. So the first thing would be your resume. Don't get too fancy with your resume. Sometimes when you format certain ways, those edits do not always come across in our application system and it actually can be harder for our reviewers to read. There are a lot of great samples on Microsoft Word or on the internet which have just basic formatting, which is fantastic. Make sure the data matches what is in the application, especially around your academic background and your professional experience. For your personal statement, make sure that you answer all the prompts. We ask these questions for a reason. For letters of recommendation, we require 2 letters of recommendation and 3 for certain programs. Make sure that your recommender agrees to write you a positive letter of recommendation. We see a lot of short, unenthusiastic letters of recommendation, and this could hurt your application. We do not require that your letters of recommendation be on professional letterhead, but when possible, it is a best practice. The application fee. We do not waive the $90 application fee for any reason, and this fee must be submitted to have your application reviewed for admission. Transcripts. You must submit all transcripts from any schools that you have attended. So for instance, let's say you went 2 years to a community college and then you switched to your 4-year institution. Even though your 4-year institution has those community college credits listed, we still need the original transcript from that community college. That's just an example. If you were a transfer student from, let's say, Tulane to Tufts, same thing, we need to see both those transcripts. Please submit an unofficial transcripts from each university or college where you earned course credit. Your transcript must be in English. Transcripts must include courses taken, credit hours, and grades earned. Official transcripts and evaluated transcripts are only required if you are admitted and choose to enroll. Again, so official transcripts and evaluated transcripts are only required if you are admitted and choose to enroll. For English proficiency scores, are required if you are a non-US citizen whose first language is not English. We will go into that in more detail in just a few moments. The GRE score is not required for any program. If you choose to submit your GRE scores, they must be official and sent directly from ETS. They will need to be from within the past 5 years to be valid. The GRE can be a great option if you've been out of school for a long time and you want to show your quantitative ability or supplement any lower grades. And lastly, we have a wonderful checklist. So once you submit your application, you have access to a checklist landing page. You can access this at any time to see the status of your application. From the checklist, you will be able to send reminders to your recommenders or change and update them if needed. We will send you emails notifying you that your application is incomplete, but please know it is your responsibility to complete your application. So next, English proficiency scores and waivers. So applicants that are non-US citizens and those whose first language is not English must submit an English proficiency score. Scores must be official and sent directly from the test center. We will not accept them through email. We do not prefer one test over another, so we encourage students to take the test that is more efficient for you. We do accept the various at-home options. As for waivers, these are processed automatically. Once you submit your application, our system is able to tell if you qualify for a waiver. If you meet any of the criteria mentioned on this slide, the requirement will be waived. However, this waiver will happen as soon as you submit your application. Again, the application is currently open, and if you haven't already, you can begin your application. Applications are due on December 16th. Some programs utilize rolling admissions, but not all, so you can expect your decision by early April at the latest. Again, the application deadline is December 16th. And lastly, if you have any more questions, you want to request more information, or you want to attend another event, feel free to scan in any of these QR codes and they will take you to our frequently asked questions database, an area to request more information, and you'll also see any upcoming events that we have. We do have a coffee chat for PhD students and various Ask Admissions webinars. And with that, I will hand it over to Bioengineering.
All right. Okay, let me actually share my screen first. All right, so good morning, everyone. My name is Dan Ha. I actually chair a graduate admissions committee in bioengineering, a professor in bioengineering as well. So I'd like to welcome everyone to this webinar. And so let me I prepare a slide deck to kind of walk you through, some essential things about our department and also the interview process in general. Okay, so just so you know, there's going to be actually a student panel session after this. And so I think, they'll talk more about what it's like to, be a bioengineer and conduct bioengineering research at Penn. So hopefully you will find, that session helpful. But my goal here is to, again, like I said, provide a general overview of the department and also walk you through what to expect during and after the interviews and so on. Yeah. So Jacqueline already gave a great overview of Penn Engineering, Penn in general. So I'm going to just skip this, but I'd like to point out that, we're known to have started the very first medical school in the country. If I remember correctly, it was started back in 1765, a long time ago. So I guess that this is what this, part of this, session is for. So let me actually tell you a couple of things about Penn Bioengineering. I'm not sure if you know, but we're actually the very first bioengineering program in the country that started, back in 1920s, which makes us over 100 years old. And we are also known to have awarded the very first PhD degree in bioengineering in the country in 1953. So fast forward in time, this is where we are now. I would say, bioengineering faculty, labs are spread across the campus, but the bioengineering department of bioengineering is headquartered in this building shown here, called Skirkanich. It's actually named after the donor, Peter Skirkanich. And as you can tell, like you will see, actually, hopefully you will see, we will have an opportunity to kind of, look at this building in person. And then also it has a very modern facade and it doesn't quite fit the decor of the rest of the campus. I always say that, but so this is where we are now. A couple of things about the Department of Bioengineering. So it was officially formed back in 1973. So we celebrated the 5th anniversary last year. And we actually started as a small department, but we've grown actually and expanded quite a bit especially over the last decade. And now we have about 52 faculty members, and I would say 30 to 35 faculty members are core faculty members, and the rest have a secondary appointment in bioengineering. And like I said, our department has grown quite a bit, and now we have well over 350 undergraduate and 200 grad students as well. So this is actually one of the questions I get a lot. So when you apply, you'll actually descriptions of these two entities on campus. One is the Department of Bioengineering, and you'll also see quite a bit actually, this another group or entity called the Bioengineering Graduate Group, BGG. So let me just, maybe try to actually help you better understand what the differences are between these two groups. So, BE, the Department of Bioengineering, you can think of it as it's just, traditional, or the Department of Bioengineering in a traditional sense, whereas Bioengineering Graduate Group, BGG, actually, you can consider this educational program kind of organized around specific areas of research, all focused on bioengineering, okay? And another way to actually kind of make this distinction is the Department of Bioengineering belongs to the School of Engineering and Applied Science, SEAS, whereas BGG, represents a much broader community, including faculty and labs, not only in SEAS, but also School of Arts and Science, Medicine, Dental Medicine, Vet School, and so on, okay? And because of that, BGG, includes a lot more faculty members and labs. It's well over 100 faculty members, again, across the Penn campus. So all these labs are currently working on one or more of these 16 specific areas of research that, chances are you're going to see actually these areas of focus and concentration areas when you apply to our department. Okay, so for the rest of this short presentation, I would like to go over two quick things. One is I would like to walk you through the degree requirements actually for obtaining a PhD degree in our department. And the second thing, which I think is going to be maybe more interesting and more important, is I'd like to actually explain the process of interviewing applicants in our department and what to expect after the interviews. So this is some stats here. It takes somewhere between 5 and 6 years, to get a PhD degree in our department, in the Department of Bioengineering. And so these are actually important milestones I'd like to quickly, explain. So there are a couple of important milestones, especially that you're expected to meet in the first 3 years of your PhD studies. So first, all the incoming students in our department, in our bioengineering graduate group, I have to say, are expected to take the qualifying exams in the first year, and then get that out of the way. So qualifying exams are these are written and oral exams. So written part is where you're asked to write a 7-page, NIH R21, if you're familiar with the format at all. But basically, it's a 7-page proposal, and you're given a general topic, and you're actually asked to develop a research proposal, based on this topic given to you. And then you would also give an oral presentation to the qualifying exam committee after the written portion. and you're supposed to defend your proposal. So, and then also all the incoming BGG bioengineering graduate students are expected to complete their coursework within the first 2 years. And what I'm showing here is basically the breakdown of the coursework requirements. And also important thing to remember is sometime actually in year 3, you're also expected to form a thesis committee and develop a thesis proposal with your thesis advisor and defend the proposal in front of the committee. And then, the rest of the training will focus on getting the data or, get the studies done that you're proposing, and then get out of here, in hopefully 6 years, well before 6 years. Okay, so interview and admissions. And so I'll be quick here. So this is actually one way to describe our interview process. So what's going to happen is, as a chair of the Bioengineering Graduate Group Admissions Committee, I get to, look at every single application coming to our department. And so we have a admissions committee, and give it or take, we receive approximately 1,000 applications every year. So what's going to happen in December and early January is we as a committee will review all these applications submitted to our department. And we, our task is to pick, more competitive applicants, and somewhere between 50 to 60% of applicants are selected. And those applicants actually, or their applications will be made available to BGG faculty members for their review. And then we'll actually select students that will be invited for on-site interviews. And so that is to happen sometime in January. So let's say you get invited for on-site interview on campus, then what's going to happen is you will have interview meetings with several faculty members in our department that you're interested in interacting with, speaking with, and also faculty members will review your applications and select the ones they would like to interview. So after these interviews, we'll actually receive feedback from you guys. The same thing is going to end. So for those purposes, keep an eye out for these emails. And these are simple Google forms where you can indicate which faculty members you're very interested in working with, and also the levels of interest for those specific faculty members. The same thing will happen on the other side of the equation. We would actually seek out the faculty feedback after those on-site interviews, and we try to actually, match students, applicants with the faculty members. And so that's how the offer letters are generated actually in our department. So we try to actually match each applicant with 1 or 2 faculty members, and those faculty members who have expressed great interest in working with you will be named on your offer letter. So oftentimes we, find ourselves in situations where more than 1 faculty member is interested in 1 applicant. Then in those cases, we would actually generate something called rotation offers or joint offers, where the admitted student would rotate through these 2 labs in the first semester, and he or she would be asked to or expected to decide which lab to join towards the end of the first semester. And also another common situation is, single offers or solo offers. So you are interested in faculty A, and faculty A is all interested in you. And when there are no other faculty members actually, expressing interest in your application, then we generate those solo offers where you would actually be directly matched with that, professor, and then you would actually start working in his or her lab right from the beginning. So those are called solo offers. But, we also have seen many situations where, the student would be admitted to the department and would rotate through 2 labs, and the students is still not happy. Then in those cases, you can always talk to me or talk to the chair of BGG, Professor Yale Cohen, and also explore opportunities for additional rotations. And you always have to to leave the lab if you don't like things, that are going on in the lab, or, if you somehow don't think you're going to be good for that lab. And so all this is to say that we're here to, listen to your feedback and also help you, settle into one of those labs, on campus, so that you can, get started on your bioengineering, PhD projects towards your thesis. Okay, so I'll actually stop here. And like I said, there's going to be a student panel discussion following this. And so you'll be able to ask a lot of questions to these guys. And also, they actually, I believe they have also prepared a presentation about, bioengineering student activities on campus. So I'll hand it over to them now.
Hello, my name is Olivia, and I am a fifth-year PhD bioengineering student. I'm also the one of the co-presidents of the Bioengineering Graduate Student Association on campus.
My name is Mohammed Sabib. I'm a second-year PhD, and I'm also one of the co-presidents for the Graduate Association for the Bioengineers on campus.
And we're just here to give you an introduction to our program, and then we'll stay on and answer questions for students that have them. We also have a resource that we'll offer at the end of our talk where you can get more direct one-on-one mentoring from other PhD students that are currently at Penn to help you with your application and admissions process. So to begin, welcome to Philadelphia. This is where we are currently in the state of Pennsylvania, which is highlighted here. You can see there's also New Jersey on this map, and New York is about an hour and a half away. Philadelphia is home to several major sports teams, as well as some cultural iconography that you'll probably be familiar with, including the Liberty Bell and Benjamin Franklin. We're also home to a lot of arts and sciences and nature. So this is a view of West Philadelphia, looking out onto Center City, or like the sort of the city center of Philadelphia. You can see in this photo on the right, the hospital system, where the hospital of the University of Pennsylvania is located. The engineering quad is right next door, and then the undergraduate campus is this green area. And so everything is very compact and walkable in this urban campus setting.
Yeah, so there's a lot of different things you can do while you're living in Philadelphia. There's always a million different things to try out or to look at or to spend your weekends at. We have a lot of museums, including the Franklin Institute and the Philadelphia Museum of Art. There's a lot of different attractions. So we're basically where America got founded, Independence Hall. A lot of art at the Magic Gardens. We are a really good food scene, and you have to of course, always make sure to try out the Philly cheesesteak when you come over. And Wawa is always great late at night. There's a lot of different sports teams out there. We have like a very strong sports scene, and like a lot of people have, I think in terms of other musical and performance arts, we have the Kimmel Center in Fillmore to watch various performances, and a lot of different artists come from Philadelphia, actually, like Mel and Lil Uzi. Yeah, so we've been running the bioengineering program for a pretty long time. The first bioengineering PhD at UPenn was awarded back in 1953. Our program has been expanding over time. We have nearly 52 faculty in the BE department, but in the broader BE graduate group, there's more than 250 folks total, which means that you have a very large number of folks to possibly match with. The number of PhD students in the program is more than 400. So we have a very large community. We're the number one university for NIH training grants, and we receive $1.5 billion in terms of research budgets from the NIH. So we always have funding is no concern if you come in.
So just to more graphically explain the bioengineering graduate group, so we have 52 bioengineering core department faculty where students can, of course, obtain their bioengineering PhD and do thesis work with. But we also have probably the majority of our students working with faculty members who are a part of the bioengineering graduate group, so outside of the core faculty, and they range from being in the School of Medicine with radiology, pathology. They can also be with like science and arts. So if you're looking at like biochemistry and biostatistics and epidemiology, and so there's a huge wide range of research areas that bioengineering supports. And we have PIs and students in all of these different areas. And so we welcome a diverse number of backgrounds into these different categories, and we support a lot of students who have very diverse research interests.
Yeah, so this is another overview map of UPenn campus. You can see on the left-hand corner basically a lot of the hospital complex, and near the center of that map is near the center to the right of the map is basically a lot of engineering buildings. So everything is really close to each other. Bioengineering has a lot of collaborations with the medical center. You can see here a lot of the engineering buildings and the engineering quad, and these are the hospital buildings. And so oftentimes I find myself walking in between the two a lot of times, and you'll find ways to collaborate between a lot of this when you come here.
So some
Yeah.
quick facts. The average PhD takes around 5 to 6 years with a median of 5.3 years. We focus on having an efficient, research-focused, and flexible program curriculum. And so you are not required to be a teaching assistant in order to enter and complete your PhD. It is optional. Students who are interested in teaching can be paid for their teaching assistantships. You'll take a qualifying exam in your first year, which Dan talked about. You will be able to solicit feedback from people in your lab as you develop your proposal for your qualifying exam, which has both a written and oral component, and is meant to help set you on the right foot, as well as direct sort of any additional coursework that you may want to take. We do have a highly flexible course curriculum, so students have a lot of freedom working with their PI and determining what sort of classes that they want to take. And then we do have optional rotations for students who come into the BE PhD program. We also have a competitive stipend at $41,500 per year in this current year. So for those course requirements, we have these categories where you need to take 3 bioengineering fundamentals, 2 mathematics, 2 biological science, and then 2 electives. And then you will also take a BE seminar where you will learn more about the skills that are required for your PhD, including paper writing and grant writing. Many classes fall under multiple of these categories, so you have a lot of options to move around courses, and then students typically take these classes in the first 2 to 3 years. Some students may want to get their coursework out of the way, and so they'll take up to 3 classes per semester. Other students may spend more time in their lab in the early part of their PhD, and so they may extend their coursework out into their 3rd year.
Yeah, I think like for the first year, you basically spend a fair amount of your time just either rotating or doing a direct match. For my first year, I mostly focused on just coursework, and in general, it's a lot less research heavy. By the end of the first year, you spend your time doing a qualifying exam, which basically tells if you're going to go forward with your PhD or not. Generally, everyone passes the qualifying exam, and if not, you just have to do a retake later on during your PhD career. During your second year, you continue to take coursework. There's more of an expectation that you're beginning to settle into whichever lab you decided to be in, and you're adding more research in. By your third year, you're trying to finish up your coursework, and you're doing far more research while preparing yourself for your oral dissertation proposal. Usually, a lot of people finish their oral dissertation proposal at the end of the third year, by which point they basically become PhD candidates. In fourth year and beyond, you spend all your time doing full-time research, and you're focusing on like finishing up your dissertation so you're able to graduate on time. I think in general, in terms of mentoring and advising, you have to, first years have to do an annual individual development plan to help make sure their goals and the goals of their PI are well realized and understood between everyone. By the time you start doing a dissertation, you have to do a semi-annual dissertation committee meeting so folks can understand like exactly what you're doing and keep in contact with the dissertation committee. And you also have to do annual dissertation progress reports to just make sure that you're on track and you're not falling behind or that there aren't any sort of like roadblocks. We do want you all to like be able to graduate on time and to be able to move on to your next part of your career.
So several people have asked in the chat already, how do you locate a PI at Penn and how do you find a lab at Penn? It is our strongest advice that you reach out to PIs in this application process. At this time, you should be understanding why you want to go to Penn and what kind of research you would like to pursue. It is then on your responsibility to try to reach out to these PIs. This can be a little bit difficult, of course, sometimes because they are very busy and they do receive a lot of emails, but I think it demonstrates a good stewardship and interest in PIs. And so you want to keep reaching out from now until basically April 15th, as there are always opportunities to basically make connections and determine whether or not that PI is going to be a good fit for you as you pursue a 5-year-long relationship with them. Yeah, go ahead, Momo.
Yeah, so basically to find a lab at Penn, it's basically a match-based program. So you first off complete the application. That's the first step you all need to do. I think it's due by December 16th. Or the second thing is you have to complete a pre-interview that's virtual. It's a necessary step to continue on with the process. And this is just to make sure that the PI knows what you're doing. It should be sent out sometime in mid to late January. During interview weekend, we'll have 3 of them throughout between February to March. And for international students, we'll have a virtual interview weekend. During this time, you'll get to know Philadelphia, and you'll also get to interview with a few different PIs. After your interview weekend, you have a post-interview weekend ranking. So you basically just try to tell like which PI you're willing to work with, and your PI gets sent out a similar survey. If both of you are able to continue, if both of you rank each other highly enough, you will be matched. And the interview isn't really the end of the process anyways. You are allowed to continue contacting folks after the interview to see if you can to see if other people are still interested in you. By the late March to early April, if there are some PIs who are interested in you, you will get an offer letter, and the offer letter will you can like arrive at Penn by mid to late August when you'll start your academic journey here.
So Dan kind of talked about this already, but there are direct matches at the Penn Bioengineering program as well as rotations. And we definitely want to make sure that you land in a good spot. So we can even help if there are a need for 3 rotations, but this is something that doesn't normally happen because normally in your interview process and in your rotations, you're able to foster good communication and sort of identify exactly what program and lab that you want to be in for your dissertation. Penn Bioengineering also offers this NIH, NIBIB, HHMI interfaces program. I'm a alum, or I guess a part of this program. It's specifically for students interested in medical imaging. You do take the first 1.5 years of preclinical coursework through the Perelman School of Medicine. And so you are essentially a medical student for 1.5 years. And the goal is to be able to develop the language and skill set in order to do clinical translational research. And so you really gain the insight of what it's like to think like a doctor and how to help patients and how to grow and make innovations in that space. These are the interfaces contacts, and you can find more information on the interfaces website.
Yeah, outside of the classroom, there's a lot of different things you can do. We try to make sure that there's always different events available, and Philadelphia is a really nice city to just explore social life and to really enjoy yourself. There's a ton of extracurriculars. We always have a big focus on wellness, social events, and outdoor trips. I think there's a graduate group that tries to do hiking trips every once in a while. In terms of in terms of extracurricular events that are organized within the department, Gabe is often like the main place that organizes a lot of the social events. So here's a timeline of the various events that Gabe tries to like run over time. We will have, if you get a minute to UPenn, we'll organize a first year retreat for you. It'll be a really nice place, usually a museum, and we get to have you talk and discuss about bioengineering and learn more about the bioengineering program and more about each other and the cohort. Gabe has its elections between September and October, so that's a really good time for you all to be involved and get involved with folks. And it's a really good way to make friends as well. We organize various holiday parties and friendsgivings. And yeah, we also have various different clubs here. So if you're interested in any sort of club, we have it here. And some of them are a bit undergraduate focused, although many of them are also graduate focused. So any club you want, oftentimes it exists.
There are other opportunities on campus, especially if you're interested in entrepreneurship. There's the Center for Innovation. We have a healthcare consulting group. And then if you're interested in doing more teaching or learning, we do have a certificate that we offer at Penn for graduate students. Outside of those resources, there are central houses, which can help with more specific affiliate needs or affiliation interests and things like that. We also have academic resources for coursework or if you're TAing and international support as well. Finally, we have a dedicated career services department, which is also very invested in helping you find success in your postgraduate career. And so this is something that you can be in touch in from the moment that you come onto campus. So we're gonna wrap up here and go into a Q&A session. I will go ahead and plug this applicant support program that we have this link to listed. I would highly recommend that if you're interested in getting any additional feedback on your application materials to sign up for the applicant support program. We do offer one-on-one 30-minute mentoring from current PhD students here at Penn. This is specific for bioengineering, but again, I wholeheartedly recommend it. I think that this can be something where you get feedback from a Penn bioengineering graduate student about your application, and then you can directly get some of your questions answered. So with that note, I will end our session, and I welcome any questions for Momo, myself, and I believe Carlos has joined. He's another Penn BE student, and happy to take any questions.
Feel free to use the Q&A box for any questions that you may have, and then they will be read aloud from there. Again, please use the Q&A box for any questions that you have, not use the messaging area or raise your hand. We ask that you please use the Q&A box. Thank you.
I see Olivia Jones writes, would the NSF-GRFP affect our admission into UPenn? I think someone's writing an answer to that, but in general, having a fellowship is always a plus if you have your own funding. It doesn't always guarantee getting in. You still need to make sure a PI is willing to like take care of you and provide the mentorship, but you know, having funding is definitely a huge plus. Someone said, is the selection done on a rolling basis or the selection process starts after the deadline is passed?
It's after the deadline is passed, so there is no rolling admissions for the bioengineering PhD. Another person asked, if you have a master's degree, how will it impact the duration of the PhD? It a little bit depends on the work that you have done in your master's. In some cases, if you have a master's, you may be able to jump more quickly into independent research, but that's not always the case. And in general, most of our BE PhD students come in straight from undergrad, so without a master's. And so everyone has an equal opportunity to, again, complete their PhD in that average time frame, which is about 5 to 6 years. But of course, on an individual basis, that can vary a lot based on, again, work that you've already done or experiences that you've already had prior to entering the PhD program. it's not too late to apply for the applicant support program. You can go ahead and follow this link and sign up for one-on-one mentoring if that is something of interest for you. The ASP link should be in the chat. Oh, I see it's only been sent to hosts and panelists. Let's try to send this to everyone. So there is in the chat for everyone. Carlos, do you want to answer this question? What would you see as both unique attributes to Penn's bioengineering PhD program? What differentiates us from other programs in the US?
Yeah, I think one really strong aspect of Penn Bioengineering is that we work very closely with Penn Medicine. So actually my PI is primarily in the School of Medicine. So there's like a lot of overlap with people working at Penn Medicine. So you get the opportunity to work if you're interested in with clinical data and also like translational research opportunities. I also think as a program, there's like a lot of support in terms of the interest groups at Penn. So I do a lot of immunology work. So Penn has huge institutes for immunology and immune health. So there's a lot of opportunity to collaborate with other PIs. If you're very generally interested in a field, but you might not have a PI that covers every single thing you're interested in, but there are people you can reach out to and collaborate. And I think that's really unique in Penn, how big our grad group is.
Yeah, I will say that the University of Pennsylvania and the Perelman School of Medicine are very well known for biomedical and bioengineering research. And so you have a lot of opportunity to be a part of innovative and leading edge research and a lot of access to people who are doing very cool things.
I see there's a question about the virtual pre-interview. So for the virtual, so basically how it works is when your initial application is sent, there's oftentimes a virtual pre-interview round. So what that means is that PIs who looked at your application and who are interested in you might reach out to you to conduct a virtual pre-interview beforehand. So this happens before and the actual interview weekends, with that being the PI will do a virtual pre-interview to decide if they wish to send you an invite to interview. So this typically happens in January. I did a couple of them myself. So it's typically a short, maybe 5 to 10 minute virtual interview where you introduce yourself to a PI who might be interested in inviting you to interview. They'll ask you a couple questions about your work and they'll basically be trying to see if your interests align enough for them to invite you. And if you're interested enough in them to get invited to interview. And that will typically happen in January.
I absolutely think you should write down any names of PIs that you are interested in. I think that when you are writing your application, you should think about both which lab do you think would be a good fit for and why they would be a good fit for you. And addressing that in your application is one way to really stand out. Some PIs may not be listed on the website yet, or they may be smaller labs, but they will look and see who you've written down. And if their research interests are similar, they may also reach out to you. So it's really important to signal to the application committee which PIs and labs you're interested in and what kind of research you're interested in, because it will help you be highlighted to other PIs who you may not have written down.
I see someone asked about being co-advised by 2 faculty members in the department. One of them is a new PI who hasn't built their lab yet, and the other one is a professor of neurology, neurosurgery, and bioengineering. Could I still apply to bioengineering to work with them both? The answer is yes. I think like in general, just like talk with them about it. You should be fine. I think like the bioengineering program is pretty flexible, and just talk with the professor and PI and ask them if bioengineering is an appropriate major that they want to like recruit from, and that if it would work for you, especially if you have a specific PI in mind and you've been in contact with them.
So all PIs are encouraged to send a pre-interview before interview weekend. And again, this is done just to sort of meet you a little bit before you get invited for the whole weekend, and to check in with you and see if you're still interested in coming to Penn and completing an interview at Penn. It's not something that is extremely formal, but of course you should prepare for it like it was a normal interview. Again, this is all done to try to optimize and help you find the best match for yourself.
Yeah, on that note, I would say to my knowledge, it's not done for every applicant. At least I know some graduate students who did not do the virtual pre-interview but were invited to the interview stage. So I do think it's a bit PI dependent. Some PIs do go out of their way to go and do the virtual interviews. Some PIs do not. So it's a bit dependent, I would say.
You have a high chance at getting invited to interview weekend if you get a pre-interview invite. Yeah, I think like in general, I think so if you are able to make a good impression on the PI who is doing the pre-interview. I think the best way to improve your chances for getting an interview or at least being matched in to UPenn is just reaching out to PIs and professors who are willing to match with you or who have similar interests with you. Make sure to send your resume and exactly what you want to work in, and ask if they can take you, if bioengineering is a good program to apply into for them to take you in, and ask about like if they can't take you, if there are other PIs they know that who would be willing to take you.
To address the question about listing faculty who are part of the bioengineering graduate group, all bioengineering graduate group PIs who are looking for students will have access to these applications. So it is very important that you list them so that they know that you are interested in working with them. Some of the questions that were maybe more about your personal statement, we again would direct you to the applicant support program, which the link we've put in the chat, where you can get one-on-one actual feedback on your personal statement. Your personal statement is the only way you can sort of tell programs and PIs about yourself, since your transcript will look maybe similar to other students, depending on your background. But your personal statement really tells your story. And so we highly recommend getting feedback on that. It is both important to be descriptive about what you did, but also be succinct. So you only have 2 pages to write your story, and you absolutely have to answer the question of why you would like to get a PhD and why getting a PhD at Penn would most benefit you and your career.
I think someone's writing do interviews only occur with people you list as interested on the application on the personal statement? I think like we don't always do that. Sometimes there are PIs who are just interested in you. Sometimes it's PIs who are completely different fields from you. And it's oftentimes just there to like make sure that, you're able to interface and network with people from other fields and are able to, at the very least, show some intellectual scientific curiosity. I think you should be able to, I think in general, don't worry too much about only the PIs you get interviews from. You can continue to email people afterwards as well.
Yeah, I will add on that once you are invited, if you are invited to an interview weekend, the people you can interview with are not at all limited to whoever you mentioned interest in before in any of your earlier statements or any of your earlier application materials. So you can get invites from professors you didn't list interest in before, or if you have the chance and have time in your schedule, you can try to reach out to schedule additional interviews with interested PIs during the week of but you're not limited to who you list in the initial application.
Okay, and I think with that, maybe one more question for bioengineering, and then we're going to wrap up that portion of the program and switch over to mechanical engineering and applied mechanics.
I'll take this last question. When you answer the question of why Penn, so this is for obviously bioengineering and also mechanical engineering, you need to talk about like why Penn as an institution will support you and why it is a place that you want to be for the next 5 years. The University of Pennsylvania and the faculty that you're interested in working with are making a clear and obvious investment in you as you decide to work here for 5 years. And so it's good to do your due diligence and do your research and really think about whether this place and the things that it has to offer really suit your unique interests and would help support you in your career and for you to achieve the goals that you have for yourself. And so it's not just about the faculty, but of course the faculty are also here for a reason. So just think about these things. And if you need help, we are happy to answer that more offline and provide resources.
Thank you so much, bioengineering. That was wonderful. And again, if you have any other questions, I know that they put up information to get in contact with them, but feel free to put them in the Q&A and we can also send them their way after the program. But with that, we're going to bid adieu to bioengineering and welcome mechanical engineering and applied mechanics.
Hello, Jacqueline.
Hi.
This is Prashant Purohit. I am the graduate group chairman of the Mechanical Engineering and Applied Mechanics program. What I want to do is share my screen with some slides that I have. So, shall I do that?
Yes, you can.
Give me just a second.
Perfect.
Can you look at it? Can you see it?
Yep, you're good to go.
Very good. So, ladies and gentlemen, I am representing the Mechanical Engineering and Applied Mechanics graduate program here at Penn. I'm the one that is running the PhD admissions, but there is, of course, it's not just me that is working on these things. There's a lot of other people. And one of the main people that is involved in the whole process, maybe some of you have already communicated with him, is Peter Litt. Peter Litt is also on this call. There are a couple of faculty members who will be talking to you a little bit later about their research. But before we get there, I want to introduce you very briefly to what goes on here in the PhD program in Mechanical Engineering and Applied Mechanics. So we have the Mechanical Engineering and Applied Mechanics graduate group that comprises 48 faculty, as I have listed here. 26 of those faculty are primary faculty in the Mechanical Engineering and Applied Mechanics department, and there are 22 faculty from other departments as well, all over the university and the school, including those in engineering like chemical and bioengineering or computer science, in other schools like the School of Arts and Sciences, Earth and Environmental Sciences, in the School of Medicine, like in physiology, and so on. Let's see, I want to make sure this is progressing. We have several lines of research within the department here, within the graduate group. I'm going to list them in order and give you some examples of faculty who are working in that area. Here is fluid mechanics, a big part of the research that is happening in our department. And we are operating all the way from the level of microfluidic devices, which is used in diagnostics for medicine. One of our new faculty members, Shuji Yang, who is right here, he works on these kinds of devices. Paolo Aratia, he's a professor in the department for many years. He has been working on microfluidic applications, Haim Bao as well. So that's a microscopic scale. We also operate at the scale of the whole Earth. And here is Annie Xie, who works on flows in the ocean to look at what are the temperature conditions, what are the other conditions that are that will govern climate change, for example. And she does it using a mixture of robotics and fluid mechanics. We also have people who do computation. Howard Hu is one of them. and so on. Current faculty who have just recently joined the department, Nathan Wei. He is a young faculty member in the department. He works on problems which have to do with wind energy, also a little bit with robotics to study environmental fluid flows. Shuji Yang, he works in acoustic mechanobiology and, like I said to you, microfluidic devices and trying to figure out what's going on at the microscopic scale within fluid mechanical problems, especially related to medicine. We also have research in energy and thermal sciences. There's a lot of activity in this area, as you all might know. There is a few faculty in our department that have been doing this for a while. Haim Bao has been doing this for a long time. Magnetohydrodynamics is one of his subject areas. Jennifer Lucas, more focused on heat transfer, especially at the microscopic scale, but other problems as well. Igor Bargatin, he runs the undergraduate program in the department, but he is been working on problems related to collection of thermionic emission for energy. More recently, he has also worked on problems having to do with space exploration. I'm going to tell you a little bit about that in the next slide. Samantha McBride, very young faculty member who has recently joined. Her focus is primarily on energy and sustainability. You'll hear a little bit about her research down the road in this hour. So I already told you about Samantha, interfacial phenomena, water and energy sustainability problems. There's a broad variety of problems at the interface of chemical and mechanical and bioengineering that she's working on. Igor has been working on micro and energy conversion devices. Already told you about that, but a large part of his effort is also focused on nanoscale materials. And here is an example of a little nanoscale material that he has made, which looks like an egg carton. It's really just 50 nanometers thick, and it can remain flat even when it is being 50 nanometers thick and on the scale of centimeters. What does he use these kinds of things for? He has plans, and he has demonstrations which show that you can make a big umbrella out of these things, like a solar sail, and that can be used for propulsion into outer space using the wind of particles that is coming out from the sun. So those are the kind of problems that Igor has been working on. A big part of our department is dedicated to robotics. There's a bunch of faculty that I have listed here, not just in our department, but also in other departments within the school. Anisia, I already mentioned to you. Vijay Kumar, he's the dean of the School of Engineering and still doing research big time. There are other people. Mark Yim works on modular robots. Cynthia Sung works on origami and kirigami type robots. Michael Poza, more on control and dynamical systems. George Papas has been in the department working alongside with PhD students for a very long time. Nadia Figueroa, another young faculty member working again on problems having to do with control of these robots. So here I already mentioned origami-inspired fabrication. So you can say that Cynthia is somewhere in the middle of manufacturing and robotics and coming up with very creative solutions to problems in this area. Michael Poza, he works primarily on these legged robots. These are the models that he's actually working on, but a lot of theoretical work involving machine learning as well as control and dynamical systems. My own area of research is mechanics of solids, mechanics of materials. Again, we have a big contingent of faculty that work on these problems here at Penn. There's a broad variety of problems that we work on, from the macroscopic to the microscopic scales. Rob Karpik looks at tribology. Pedro Ponte works on composites. Myself on problems having to do with biomechanics, particularly fibrin networks, blood clots at the moment. Jordan Rainey, architected materials. Celia Reyna, non-equilibrium statistical mechanics, applied to problems in solid mechanics. Ortman Tertuliano, he's working on bone and also on microscale manufacturing. Kevin Turner, he's the department chairman, and he has worked also on a broad variety of problems having to do with adhesion at the microscopic scale and fracture. Already mentioned to you, Jordan Rainey. Again, he's somewhere in the middle of manufacturing and mechanics of solids. So coming up with various methods of 3D printing and then applying it to problems in solid mechanics and dynamics is something that he has done. Nat Trask, one of the newest faculty members in the department, used to be at Sandia National Labs earlier for a long time as a project leader. And he works on problems in machine learning and artificial intelligence applied to fluid and solid mechanics. A specialist in finite elements and many other computational methods. Rob Karpik, I already told you, tribology. Kevin has been working on adhesion problems at the microscopic scale. Just as an overview, we have a total of about 80 PhD students in the department. 15 new PhD students joined this fall. It's a typical number. It ranges anywhere from about 12 to 20, or maybe sometimes a little bit more than 20 as well. There are plenty of students with external fellowships, including those from the Department of Defense, from NSF, the underrepresented minority PhD students in the department. We also have a vibrant master's program. Currently, there's 160 students in that program, and on the order of 60 or 70 students join every year. All students, stipend and tuition is completely funded during the course of their PhD. Mostly this is through the grants that the advisor is getting from external sources, including National Science Foundation, National Institute of Health, Department of Defense, Department of Energy, and so on. Median time to PhD is about 5.2 years in our program. I have had students that have completed anywhere between 4 and 5 years. Modest course requirements. There's 10 courses that every PhD student has to do. 3 of them are MEAM core 2 math classes and 5 other classes typically related to research. There are ancillary courses that students do. They also have to do a teaching practicum, typically 3 semesters of TA for every PhD student. And there are other requirements related to seminar, PhD examinations, and so on. I can go into the details of this if anyone has questions about it. Our students end up in faculty positions as well as in industry on a regular basis. People who have graduated from our department are at places like UC San Diego, at the University of Maryland, University of Illinois, Georgia Tech, so on and so forth. The number of universities are listed here, including universities in foreign countries, not just the US. And also in corporate, for example, Amazon, Schlumberger's, 3M, SpaceX, so on and so forth. So that's sort of an overview of what's going on in our PhD program and the subject areas, as well as where people get employed at the end of it. That's all I wanted to say. I don't want to take up too much time, and I'm going to hand over to the other people, assistant professors and other faculty members who want to give a little bit of idea about their research. But I am going to welcome questions at this moment. Questions, anyone?
We've been answering questions also in the chat as well. So if you have questions, please feel free to enter them there. I think our first faculty member that we have lined up today is Dr. Samantha McBride. So if Dr. McBride, I think you're here, if you can feel free to share your screens. Oh, and you are muted, sorry.
Okay, how about now? All right, everyone can see the screen? Great. All right, so yeah, I'm going to give just a quick overview of some of the stuff that my lab does. So my work is in interfacial physics, fluid mechanics, and soft matter physics at the intersection with water chemistry and environmental engineering, because my background is actually in environmental, chemical, and mechanical engineering. So there are a couple of really interesting problems at this intersection, including fouling control, resource recovery from wastewater, and then also just water treatment. And really what I'm interested in is interfacial phenomena, so things at very small scales that can really impact the overall efficiency of various processes. So one really great example of this is anti-fouling materials, where if you have materials accumulating at an interface, that can have a huge impact on your heat transfer, your desalination, or your wastewater treatment processes. So when I say interfaces, I mean the boundary between two phases on both a molecular, nano, and micro and macro length scale. And so some of the interfaces I'm particularly interested in include the air-water interface, which is important for a variety of problems in the environment. So for example, thinking about oil spills or using bubble nanotechnology as a water treatment method. And I've also done quite a bit of work at the solid water interface. So especially things like contaminant accumulation at interfaces, or how we can structure solid interfaces to have an influence on different environmental sustainability processes. So some of the tools that we use in my lab include some things on the interfacial and small scale fluids engineering side, and then also some stuff that's more environmental engineering and water chemistry. So for example, we use a lot of microscale flows using microfluidic devices, which we fabricate in the Seam Center for Nanotechnology. We also do some work with unique surface chemistries using thin film deposition techniques, which can give you non-equilibrium properties to create really unique surface characteristics. We also do some stuff with engineered topography, which is a really powerful tool to control how a solid interface interacts with a fluid. So shown here is an SEM image of a microscale device that has then been patterned with also a nanoscale texture. We do some composite interfaces. So this includes liquid solid composites to create very slippery materials that can be used for anti-fouling in a variety of applications, but also soft solid composites. And then finally, we look at different flow geometries. Pictured here is a Healy-Shaw cell, which is 2 flat plates, and then you have some porous media in between that can be used for different patterning phenomena. Over on the environmental engineering side, we look at some specific ion effects. So if you have sodium versus potassium in solution, that can actually have a really big impact on the water quality. And then at the intersection between these two areas, some of the problems we're currently working on include separation efficiency and sustainable sensors. So there are a variety of different impact areas that my group is interested in, particularly in water. So we look at materials that can allow us to have membranes that are much longer lasting in desalination. More recently, I've also been looking a lot at microplastics research. So there are a variety of health and ecological impacts of these very small scale plastics in solution. And it's really very much an interfacial problem to try and figure out, first of all, how do we detect them? And then how do we remediate them from the environment? So we've been looking at a lot of environmental remediation. We're also doing some work in CO2 mineralization, looking at microfluidic devices to capture CO2 from the atmosphere and then store it as a solid calcite material in order to improve climate change. And then we also have a few problems in resource recovery for agriculture or looking at porous media flows for groundwater remediation. So the lab itself is physically located in the Seam Center for Nanotechnology, where we make use of a 10,000 square foot clean room in order to do the micro nanofabrication of both our engineered interfaces, but then also of our microfluidic devices. And then my lab is located right next to the clean room, so it's very convenient to go back and forth. And if you're interested in learning more, my group website is smcbridelab.com. And yeah, thank you for your time.
Thank you so much, Dr. McBride. That was great. We've been steadily answering questions in the chat, but if any of the participants have additional questions, we'll continue to do that. Feel free to post them at any time. Otherwise, I think we're going to move on now to Dr. Holliday. Dr. Rachel Holliday is a member of our lab and he's here today with us. Great. Thank you so much. All right.
So just as a little bit of introduction, Rachel Holliday will be faculty in our department starting fall of this of the academic year, that is next year, fall 2025. She's currently in the school working together with Cynthia Sung, and this is again on robotics problems. We thought it's a good idea for her to show prospective students the kind of research that she's engaged in, and this has got to do with robotics.
Thanks, Prashant. Yeah, so hi, everyone. I am a new faculty member, so I'll be starting in August 2025. And so I am recruiting students this year. And so you'd be starting with me, which I think is quite fun. As was mentioned, I work in robotics. And so the focus of my lab will be thinking about how we can develop the algorithms, the frameworks, and the models to enable robots to be able to robustly perform long horizon, contact-rich manipulation tasks in everyday environments, as I'll let the videos play. And so you can imagine if you wanted to enable a robot to cook dinner in the home or to be able to clean up messy classrooms, that accomplishing those types of tasks not only requires a lot of different steps, imagine if you're cooking a meal, but that each of those steps and actions have a lot of constraints that require you to really reason over both the physics and geometry of the world. And so there's a question of how we can develop models and frameworks that enable robots to do that. For me, thinking about how we can actually put robots in the real world in everyday environments requires that we think about both uncertainty and generalization. And so in developing these types of frameworks and algorithms, our robots will not always be able to operate with complete information. We'll often be operating from partial information or no information, or the world is dynamic. And so it's really important, and there'll be a lot of focus in the lab, of thinking about how robots can reason over uncertainty, either operating robustly or exploring their environments and kind of building in that intelligence. Additionally, if we want robots, again, operating in around the world, which is what deeply hope for, is that a robot's behavior needs to be able to generalize. I think it's amazing when a robot can accomplish a very dexterous task, but to me, it's particularly exciting when it can accomplish that same task in multiple different ways, because we don't want one way for example, a robot to cut a cucumber, but for a robot to be able to cut cucumbers in everyone's homes. So accomplishing developing these types of frameworks pulls from a lot of different areas, from different areas of planning, task and motion planning, control, contact mechanics, thinking about how we can leverage both models that pull from contact mechanics and other areas of mechanics, as well as learned models. And to me, as maybe the video suggests, I have a deep love for kind of putting all of these algorithms on real robots, both because I think that is the real test of do these algorithms work? There's the point of what we want these robots to do, but that's also where the joy comes from. So my lab will be physically located in Levine. It's actually being constructed, so it'll be a brand new lab space, which I'm very excited about. I am primary faculty in MEAM, as well as GRASP, as was earlier mentioned, and then secondary in CIS and ESC. And so while this is a MEAM webinar, the lab will be populated with kind of people from a lot of different areas, because to get robots to work, we're going to pull from a lot of different areas. So I'm very excited to be starting. I recently made the decision to come to Penn, and I'm very happy with it. So I'd be happy for everyone to come and join us. And if there's any time for questions, I'm happy to take them.
Dr. Holliday, there was
Peter, I see a question
in the chat. Did you see that one? Sorry.
Yeah, so there's a question about a school of medicine developing robots for using surgery. I haven't yet explored robot surgery, but I think that would be an interesting direction to go in. I also say an interesting direction that I'd love for the lab to explore is collaborating not only with the School of Medicine, but with the School of Nursing, and thinking about how we can get robots in hospitals. There's not only kind of the surgery aspect, but if you think about all of the variety of different manipulation tasks that nurses do all around, I think there's a lot of opportunities for robots to make a really big impact. Hopefully that answers your question, Petra.
Great. Thank you so much, Dr. Holliday. That was really informative, and these videos are very cool as well. I would next like to welcome Sumit Kumar, who is a current PhD student working in the lab of Dr. Robert Karpik. Dr. Karpik is looking to recruit students this term, but he is unfortunately unable to join us in person. But Sumit is going to represent the lab, and also maybe you can answer questions about, or you can describe your experiences as a first-year PhD student here. Thanks, Sumit.
Thanks, Peter, for the introduction. Hey, I'm Sumit. I'm a first-year PhD, but I've been in Rob's lab for about a year and a half now, so I'm pretty familiar with his research. I was a master's student before I joined the PhD program at Penn. Our lab used to delve in tribology, and it still does for the major part. But the way I'd like to describe our lab is it's a pretty interdisciplinary lab. We work on a bunch of things. Some key things that we work on, and when I say it, one of my lab mates is defending tomorrow, so that's going to be cool. But one of the things that our lab works on predominantly is the use of metal oxide nanocrystal additives that protect materials against wear and failure. And that's a huge area of research that we are exploring as well. We have another interesting thing that we are exploring with, I think, James Batias's group at Texas A&M. And it's basically highlighted, and it's called mechanochemistry. It's basically the dependence of activation energies that are used to catalyze chemical reactions and the dependence on the stress that acts between two media. Saying these things, I probably work furthest from tribology because I study the rheology/tribology of synthetic mucus. So I'm more of a soft matter person. The, Rob is not here to describe and like much, but I'll say whatever Rob thinks on his behalf. He's a pretty open person, and over the last 2 years, he delved into soft matter with both eyes closed, and it has been a smooth ride. But yeah, I'd like to answer any more questions. And yeah, we're always looking for collaborations, and yeah, the lab is expanding as well.
Thank you so much, Sumit. That was great. Okay, so we've steadily been answering questions in the chat, but if we have any other questions, now is a great time to post them. Again, the timeline is that we're going to be accepting applications until December 16th. And at that point, I believe, Dr. Brohit, you're going to form a committee for initial review, and decisions will come out in late February, March, and then all decisions are due by April 1st. Jacqueline, I saw you here briefly. Do you have anything you'd like to contribute?
No, I was just going to remind students to put the questions in the Q&A for you to continue answering. And if there's any admissions, I know my team's on the back end as well.
So the bioengineering question answer session was pretty lively. I guess a lot of the questions that students wanted to get answered got answered then.
I see a question in the chat here related to motion planning and SLAM related research. I think that's related to robotics, perhaps the work of Dr. Posa. I'm not really qualified to answer that one. Dr. Holliday, do you have any thoughts about that?
Yeah, so I think maybe so there's a question about SLAM and motion planning. So I think on the motion planning side, there are a couple of us. Luckily, Penn has so many roboticists. And so motion planning, Nadia, Michael, and myself are all people who work in motion planning. SLAM would be a question of if you want to go more on the motion planning side or the computer vision. There's quite a lot of computer vision faculty, mainly in CIS. So I think that's who to look for without further details. That's where I'd point you. Submit. I think there's a question for you as well.
That's something that I'm not sure about. As far as the Musin project is concerned, I think we are not, but as I said, one of my lab mates is defending tomorrow, and that's probably something that Rob is looking for. But that being said, I'm not sure.
In general, let me answer this question, Sumit. There was a question about what particular projects that Rob Karpik is recruiting for. We don't know these things. And in general, funding, it depends upon the funding situation of the particular faculty member. Every faculty member is, interested in a large number of projects, and they keep submitting proposals about it. Some of those get funded, some don't. And which particular projects they would hire for would depend upon, the kind of funding that is available. So really, this is a question that you would get to at the later stages of the application. But overall, the broad area of expertise of Rob is in tribology and studying friction. He has been moving into mechanochemistry pretty heavily in the last several years. Mechanochemistry, works both ways: how mechanics affects chemistry and how chemistry affects mechanics. It's a very interesting area of research somewhere in the middle of these two. And so soft materials is another thing that he has gotten into. Earlier, he worked primarily on hard materials only. Think about a head reading a CD player, for example, right? So those are the kind of problems that he studied before, but not anymore. I mean, soft matter is a very important area of research these days, and tribology and rheology of soft matter is something that Rob is studying actively these days. So these are the broad areas of research that he works on, and you can indicate your interests about these things in your application.
We do have some pre-submitted questions that we can read aloud right now and then get back to the Q&A section. The first one is, I'm looking to get into automotive engineering. What are some of the connections UPenn has, and what is some of the curriculum UPenn has to cater to this?
Well, I can answer that a little bit. Automotive engineering is not something that we are directly involved in. However, the people that are working in dynamics and control and in problems having to do with robotics, their research would have some intersection with problems related to automotive engineering. So if a person were to be interested in such an area, they would go to that discipline in order to learn more, look at faculty working in that area.
Okay, fantastic. Thank you. And then a second one is, I'm currently pursuing a master's program abroad, but I'm considering leaving the program to apply for a PhD at Penn. Is it possible to transfer the credits from the courses I completed in my master's program?
Yes, it is. We have to know that they are master's level courses that you took elsewhere, and then it is possible to transfer a certain number of credits from any graduate program that you took elsewhere into the PhD program, provided the faculty member who teach similar courses here agree that this is a good idea.
Great, thank you.
I know
Another
sorry,
is,
Jacqueline, if
go
I could
ahead.
just interject 1
Yeah.
second. I saw a question earlier in the chat that was asked during the bioengineering session, and the question was something like, if you transfer classes, does that affect the duration of your PhD program? This is directly relevant that yes, it can accelerate. If the courses help you complete your course requirements faster, then you can more quickly move on to doing research, and that will obviously impact your completion.
Fantastic, thank you. Another question is, do I need a master's degree to apply for this program?
No, you can apply immediately after your undergrad is over, and you can get a master's along the way to your PhD here at Penn.
Perfect. And then if you want to return to the Q&A box if there's any, if not, I do have a few more I can ask.
Okay, so there's a question about whether a research gap after the master's degree would affect my acceptance chances into the Bio-E program. I would leave the bioengineering program to consider those questions, but I can tell you what our point of view here in mechanical engineering is. If a person has left the master's, has done a master's and then working in industry for some time, sometimes that can be viewed as being advantageous due to many reasons. If they have been working on problems, that are relevant to research here at Penn, that is an advantage. And typically those students who have had work experience outside tend to have a different mindset about the PhD than students who have had no work experience. So that affects the chances of getting into the PhD program in a good way. I would like to hear a little bit about the predictive intelligence lab of Professor Perdikaris and Professor Nattak. Are they accepting students for the next fall? I don't know if they're accepting students for the next fall, but they're actively involved in looking at applications for next year. Like I said, whether or not particular faculty member is admitting students depends upon their funding situation. But both of these people, Paris Perdikaris and Nat Trask, are working on problems having to do with machine learning and artificial intelligence, especially applied to problems in mechanical engineering. Paris has been primarily looking at problems in fluid mechanics, but also moving into problems in solid mechanics. Nat has been doing both fluid and solid mechanics from his background at Sandia and materials problems. So this is currently a very hot topic of research, plenty of funding in the area. I'm sure at least one of them would be looking for students next year. Okay, another question here. I'm currently in my master's final year. The transcripts showing the grades from 3 semesters will be given to me on December 20. Can I upload transcripts after submitting my application, or can I add additional materials? Peter, I think you would be better suited to answer this question about transcripts. Whatever transcripts you have currently, you got to upload them so that the faculty here who are in the admissions committee can take a look at your track record, right? But if something becomes available a little later, and you want to update that information, I think there is no reason why you shouldn't be able to do that.
I laugh a bit because I think actually Jacqueline, who is here from Penn Admissions, might be best suited. But to my understanding, students should upload their unofficial transcripts now, and then when they're offered admission, they will be required to have their institutions send the official copies directly to Penn. Please correct me if I'm wrong about that.
Yes, that's absolutely correct. And if you need to have your transcript evaluated, such services such as WES, you can do that too after if you have been admitted. Send those as well.
Okay, there is another question. We know that Penn is a very competitive school. Does my undergrad GPA play an important role in my application? The answer is yes. But undergrad GPA is not the only thing that plays a role in your application. It is also what kind of research or what kind of work that you have done alongside your undergrad coursework or master's coursework, which indicates that you are deeply interested in doing research. That becomes important down the road. Letters given to you by your references also play an important role. And again, the weightage of each of these things in the minds of every faculty member is different. Some people attach a lot of importance to GPA, others don't. Some people attach a lot of importance to letters, others don't. So the good thing is to have all of those things, all your ducks in a row when it comes to a good application. All those things should be good.
We have,
I'd like to learn.
Oops, go ahead.
There's about LPBF and SLM and DED additive manufacturing research at Penn. Can you please guide us about that? Thanks. I don't know what each of these acronyms means. I know a little bit about additive manufacturing, and there's plenty of it going on in our department. Jordan Rainey is working on problems having to do with additive manufacturing and its intersection with mechanics of solids, and in particular, dynamic wave propagation in solids. Cynthia Sung is working on additive manufacturing and its connection to robotics problems. And there are others. Augmented Giuliano is also working on additive manufacturing, particularly looking at microscale behavior of these additively manufactured solids in the context of biology and medicine. Are applications considered after the deadline or on a rolling basis? Applications after the deadline are not considered, as far as I know. And once the December 15 or whatever the deadline is comes, the applications will be closed, and then we're going to form a committee to take a look at them and then get back to students as early as possible.
Yes, that is. I'm just going to clarify that. That is absolutely the case, and the application deadline is December 16th. And then we actually have another pre-submitted question. If we want to go ahead and answer that, and then we can turn back to the Q&A section. Do I need a master's degree? Oh, no. What makes this program unique compared to other similar programs?
Our program? The MEAM program. Again, we are not a very big faculty. We are a relatively small faculty in mechanical engineering here at Penn, which means that it's very collegial. That's one important thing that distinguishes us. And the other thing is the proximity of the School of Medicine allows for interesting collaborations to occur. And there is several faculty members in our department that have been doing this. So I would say these are some of the unique aspects. Also, there is a GRASP lab here at Penn, which is very highly regarded all over the country, all over the world. And we are fortunate to have a large number of faculty in computer science, in electrical engineering, and in mechanical engineering, all part of the GRASP lab, work doing cutting-edge research in robotics.
Fantastic. Thank you. And then we can turn back to the Q&A, and then we can start wrapping up here, and we can add, put back up on the screen our QR code. So if anyone is interested in requesting more information or looking at other more Q&A or registering for any further events this fall.
Okay.
Please feel free to put any questions in the Q&A box as we wrap up here.
Please let me know if we apply without contacting a faculty member at first. Does it somehow lower the chances of admission? No, it doesn't. As opposed to someone who has support of a faculty member. No, it's not. It doesn't work like that. A lot of people make efforts to contact faculty members before the applications and before applying to the program. when we get applications, we look at them and we consider them all equally. It doesn't matter if you have contacted us beforehand or not. We ask you to give the names of faculty members whose work you're interested in, and we will usually direct the application that we receive to these faculty members to take a really close look at. And then they will determine the fit of that particular application within their PhD program, and if they are looking for students and so on. But to answer your question, does it somehow lower the chances of admission? No.
I see a question in the chat from a current Bachelor's of Science holder who does not currently have a master's degree, asking, if admitted, is it possible to obtain a master's degree on the way to the PhD? And the answer to that is yes, it's very common. PhD students are required to complete 10 course units. With a little bit of planning, it's very easy that you can select courses that will also satisfy the requirements of the master's degree. And once you're admitted, we can talk more about that process. Typically, students pick up that non-terminal master's in their second or third year. It's very common. That's the short answer.
There is one caveat I'm going to add to Peter's response here, and that is that the BSc degree in India and England, it's usually 3 years. You have to have a 4-year undergrad degree in order to gain admission into any of the programs, PhD programs in the US. So that is something to keep in mind. Have the majority of accepted students published a paper before? No. There is some that have, and it bodes well for them because it clearly shows that they are interested in doing research and have been doing research before. But a lot of the students that, for example, I have admitted in the past have not published any papers.
And let's do one more question and then we'll wrap up our program for today.
I have provided 3 references, but only 2 of them have submitted their references. Our Penn keeps emailing me about the missing, which is the third one. Is it important? It is important. We really ask for 3 letters for admissions, but sometimes we know that people who are writing letters can also be tardy. They may not remember to submit a letter. If 2 letters have come in, we're going to take a look at them seriously. It's always good to have 3 letters, but not always necessary.
Perfect. Well, thank you everyone for joining us. Real quick, we're going to put back up our QR codes. Should you have any more questions and want to contact anyone within the programs, we're happy to make that connection. And also feel free to join us for any upcoming events. We do have a PhD coffee chat, which is December 5th, and there will be reps from each program there to chat more. But again, thank you so much for joining us, and thank you to the MEAM team. We really appreciate it, and we look forward to seeing you at future events, and we look forward to reading your applications.
All right, guys.